Here, Patricia, Albert, and Maria from Catalan Cork Institute Foundation, ICSURI, will explain sustainability, carbon footprint, and potential products of cork. First of all, let us do a brief introduction or presentation about ICSURU. ICSURU is located in Palafrugell, a seaside village of Costa Brava, about 100 kilometers from Barcelona, Catalonia. ICSURU is a foundation dedicated to promote the entire value chain of cork products, from the forest to anything that can be done with cork. We have 30 years of experience in cork sector. ICSURU has 3 business units that are communication, quality, and research and investigation. In the Model 2, the importance of cork material in relation to sustainability will be introduced. The Model 2, entitled Sustainability, Carbon Footprint and Potential Product of Cork, the importance of cork material in relation to sustainability will be introduced. The chapter is divided into 3 sections: cork and sustainability, conducted by Patricia; cork carbon footprint of cork, conducted by Albert; and potential uses of cork, conducted by myself, Maria. The first unit will focus on sustainability. So the aim of that unit is understand why cork is considered sustainability material. The second unit will be, the aim of the second unit is to know and clarify the concept of carbon footprint and different steps of its calculation. And the third aim is to get an introduction of different uses of cork material and the characterization that make it sustainable of the aerospace sector. So let's start.
Well, let's start with cork and sustainability. This unit 1, the learning objective is to understand why cork is considered a sustainable material. And the table of content is that cork as an ecosystem, environmental services, sustainable management, and the impact of climate change on the cork ecosystem. Related to cork ecosystem, it's important to know that it's a multifunctional ecosystem with a 3-cover layer dominated by cork oak or Quercus suber and by horn oak or Quercus ilex with an herbaceous species. This tree lives in warm, humid, and subhumid conditions at 600 meters of altitude, and is well adapted to mild winters and hot and dry summers, and to soils with low fertility. Cork oak is able to adapt this activity according to other environmental conditions, such as severe summers, drought, and high temperatures. Related to the cork oak forest areas, it covers a worldwide area over 2.1 million of hectares. It covers a big area in Europe, mainly in Portugal and Spain, but also in France, in Italy, and in the northern or African countries of Morocco, Algeria, and Tunisia. According to the forest inventories for the cork oak areas, more or less, this is the numbers that it was registered. The annual world production of cork is about 2,000 tons, and the distribution map of cork oaks and cork productions is shown in this figure. So some years ago, Cork oaks were introduced in the United States and in several countries from Australia to Bulgaria and South America without success. Some aspects such as seed conservation or problems in growth of young plants have been responsible for not obtaining adult trees. The long cycle life of the tree doesn't help either. However, it is possible to find in many parks all over the world because of its height, or they have a high ornamental values. Mm, the uh, the landscape of Cork Oaks is one of the best examples of balance between conservation and development for the benefit of people and the environment. But this is a non-natural ecosystem because it's the consequence of centuries of ongoing management and focused on silviculture activities that have molded the trees and the cork oak environment. As a result of some practices such as grazing, clearing, or plowing for agriculture, cork oak forests were gradually transformed into open woodlands. Nowadays, cork oak ecosystem include a mosaic of four types of patches. Cork oak savannas or montados, it's typical from Portugal, as you can see in this image. And for example, in Catalonia, the cork oak is like a forest in Catalonia, and in Italy, like Sardinia, for example. The contribution of cork oak ecosystem goes even further to fight social and environmental desertification. This species plays a fundamental role in combating desertification insofar as it contributes to fixing soil or organic material, reducing the erosion, and increasing the water retention in these areas. In terms of social desertification, it's important to know that it allows the creation and the maintenance of a significant volume of employment in zones that are especially deprived. Related to the positive biodiversity impact, cork oak savannas are protected ecosystems under the Pan-European Network of Protected Areas, and it can be considered a biodiversity-based product system. The cork oak forest is the basis of an ecosystem unique in the world, contributing to the survival of many native species of fauna and flora. In these pictures, you can see some of these species. For example, the Iberian lynx, a critically endangered feline, or the Barbary deer, and other plant species such as scrub species or Mediterranean grasslands. In brief, some properties of cork oak ecosystem are it's a source of biodiversity. They have a high fire resistance, is a natural barrier against desertification. There are a variety of forest management, and it's also sustainable forestry. To obtain cork, it's necessary to do 5 phases: the opening of the plant, the separation, the dividing, the extracting, and finally the removing. In brief, the harvested may be divided in 5 phases, and I will explain it later. In relation of environmental services, The cork oak is one species that could be preserved, taking into account its ecological and economical importance. And this oak forest support one of the world's highest levels of forest biodiversity, second only the Amazonian rainforest. Therefore, a cork oak forest are hotspots of diversity, constitutes unique ecosystems that are recognized for their ecological value. The extraction of cork and its high value of cork stoppers is responsible of thousands of business in different levels of its production, from the forest to the lab and to the industry. In plant anatomy, cork is a tissue named phloem and is a protective tissue that separates the living cells of the plant from the outside of the environment. The cork cambium is another thing to take into account because it's a lateral meristem that helps in secondary growth and it produces the cork. When we stripping the cork, we do it manually using an axe with a curved cutting blade and a relative long wooden arm to be used as a lever for the separation of the cork plants. It's necessary to do this by an expertise to avoid the damaging of the tree, because it's very important that not affecting the vascular cambium below the phloem. Cork oak is physiologically active because and for this reason it's necessary to stripping during late spring and early summer or during the period of periderm activity when the phloem mother cells and the recently formed phloem cell are target and the cell walls are thin and fragile. In this picture, you can see a tree that is berry or cork of tree in Portugal, and even size 18-20, it is harvested every 9 years to obtain cork stoppers for wine. As you can see, the subsequently stripping of the bark doesn't damage the tree because it regenerates naturally. There is a difference between the cork barks, depending on the time that you're stripping of this material. Virgin and secondary corks, that is the first cork bark stripping, present some differences in the visual aspect in comparison with reproduction corks. These differences are due to the development of the tissue named periderm. As you can see in these first images, both first cork barks is irregular and presents alignolicid structures. That is the reason that both barks are not suitable for natural cork stoppers production. But how is possible that cork bark regeneration? So this is this happens an histologically explanation. When we're looking at cross-section of a tree stem, we can differentiate two meristems or two groups of undifferentiated cells with a cell division capacity. Both meristems are able to produce tissue on both sides. In the case of cambium, it is responsible for the formation of the xylem or wood and phloem or principal food-conducting tissue in the vascular plants. This is the typical structure of woody plants. But in the case of cork, the phloem is responsible for the formation of the phloem in phloem or cork and in the inner and the outer part respectively. The periderm is the phloem, and phloem, and the bark is constituted of the phloem and the periderm. The periderm is a protective tissue and in some species is only functional during a period of time. And this is the key of for why the remover bark of Quercus suber are not damage the tree. In brief, the phallogen has a limited lifespan, and after it's dead, a new one is formed inside the phloem. And this tissue do not lose its properties and allow the accumulation of successive periderms. The cork oak produces a periderm with special characteristics of development, regularity, growth intensity, longevity, as well as with regeneration capacity after removal, which has made this species very unique. The successive periderms, which are separated by layers of phloem, are called retidom. And the mother cell line is the sum of the phloem, the phloderm, and the phloem. In the case of Cargus suber, the mother cell layer viability is essential to phallogen activity and therefore for the cork regeneration. The stripping is done during the period of activity and the phallogen, when the young cells are fragile and fragile. And the cellular division of the phallogen is linked to the physiologic cycle of the tree, and it corresponds to late spring and early summer. And finally, as phallogen activity depends on the environmental conditions, also should be taken into account. But who is possible its suitable management? Because the cork oak is extracted from the bark of the cork oak tree. But the harvesting do not damage the tree because the mother cell layer viability remains intact. The phloderm of the cork is only functional during a period of time, and the successive deaths of subsequent regeneration of the periderm is responsible from the cork plant's production. Nowadays, the natural cork stoppers are the most valuable product on the cork industry because represents almost the 70% of the total value generated for the cork industry. But cork bark that is not suitable for the cork stopper industry are used to produce cork granules that are classified according to their density and grain size. These granules can be used as a final product in several applications, taking advantage of its properties. After stripping, the second step is the store of the plants or the first stabilization. In this process, cork plants are stored during 6 months before processing to stabilize and develop an optimal moisture content. The store is on concrete rather than bare earth, and the cork plants are positioned at a slightly high angle to prevent microbiological contamination and maximize air circulation. The second step is the boil and second stabilization, where cork plants are boiled during 1 hour at least in stainless steel tanks. And the aim are to remove organic material and to enable cork to reach the optimum moisture content for processing. When the cork plants are taken off, their volume has increased by more or less 20%. Then, for cork stopper production is necessary a visual classification of cork barks based on its appearance and thickness and porosity. The cork quality is an important factor to decide the end use of this raw material. This quality is evaluated by a visual check of the cork plants, and the classification of cork plants by an operator takes into account subjective criteria that are different according to the end use of them. In the case, for example, of cork quality for cork stopper production, the principal characteristics to consider are the porosity, the thickness of the raw cork, and some defects such as insect holes or tangential cracks. So, some examples of these defects are cork with horn holes, as you can see in this image, or a galleries caused by the larva Coroebus undatus, is a problem related to the climate change, cork with dry ear, or cork showing an eutium lignificate layer, cork with ant holes, for example, cork with belly irregularities, earthy cork that is cork with tapered lenticellars channels, cork with yellow stains, or green cork, for example. Related to the sustainable management, this is an image, as you can see, a picture that is related to the production of cork stoppers, instead a picture that is related to the synthetic or plastic closures production.
Okay, let's begin with unit 2 of that lesson about carbon footprint. We will talk about sustainability of cork, why we say that the cork is one of the most sustainable materials in the world. Then we will talk about how to measure that sustainability with carbon footprint, and why we would like to see more cork material into the aerospace sector. Okay, so during these 10 minutes, more or less, we will explain the carbon footprint, the importance of the forests, the cork forests, the methodology to calculate that carbon footprint, and we will give some examples of this. Okay. Well, the first main idea is to know that the cork material is organic, natural material. So they store carbon, they store hydrogen and oxygen in their molecules by photosynthesis. So in that sense, it's like a sink of a greenhouse gas. So it is that the tree takes CO2 from the atmosphere and maintains that CO2 into their tissues. Okay, so that's important. And we will see that the LCA, the life cycle assessment, is a good methodology in order to calculate that carbon footprint. Okay, where are we now? You know that nowadays we are in an emergency, climatic emergency. The weather is changing rapidly. We have a lot of climate events in the whole Earth. So we are committed. All the society is committed to try to decrease the frequency of climate events through try to not go above 1.5 degrees 1.5 degrees Celsius above the limit. So different countries have their schedule, their planning in order to try to avoid the emission of more GHG emissions, so GHG gases. So for many countries, the year 2050 is the year that we will try to reach that net zero CO2 emissions. So because of that, we have to try to find ways to use materials with less carbon footprint impact. So if we don't want to go or not to achieve that goal, we have to do something, and something rapidly. Okay, that's the idea for the European Commission to be climate neutral by 2050. So in that way, we have to first try to find ways to calculate the carbon footprint impact or the sustainability of different products and services, and then choose which is better. In the case of aerospace industry, is the same. We have to find ways to design and produce a better equipment for aerospace industry with better materials, with less environmental impact. In that case, we think that cork product could be interesting. Okay. Here we have different decarbonization targets of different companies, and not only the public governments, if not the companies. From time to time, more companies has that target. So it's important to not only think with aeronautics, if not other sectors has that goal. And we know nowadays that the international aviation is, well, not the main contributor to the greenhouse gases, but if we have the possibility to do something to have a better achievement, better sustainable behavior, we have the obligation to do that. Okay. Okay. Then, how we can use the cork in aircraft technology? We think that the property that is useful for aircraft technology is the property of lightweight of cork, a part of the sustainable characteristics. So if we have, for example, a lighter plane, we will use less fuel to do the travels, for example, okay, in aviation. So that, because of that, that's important. Then, one thing is the why is important in the context of the climate, and then we have the methodology. The life cycle assessment is the methodology most commonly used in order to understand the degree of sustainability of a product. Okay. The idea is simple. The idea of the carbon footprint concept and the LCA is just to try not only focus on the product, not only with if the product uses more or less energy, or it is made by more or less natural materials. If not, the concept of the LCA is to take into account all the stages of production, use, and waste or disposal of the product. Okay, that's a methodology. And then you will see that we talk every time about greenhouse gas emissions, CO2 equivalent, etc. So when we talk about CO2 equivalent, we are referring of a unit that is composed of different inputs and outputs and materials. And in order to try to make simple the calculus and the information, we resume the whole thing, the whole inputs, outputs, material, energy into one unit. That unit is CO2 equivalent. With that CO2 equivalent, we refer to everything, to all the gases that cause greenhouse gas, are part of the greenhouse gases in the atmosphere. So it's a way to simplify the calculus and the information and communication. Okay. Because of that, the LCA assessment, or the life cycle assessment, gives at the end that value. And that value of greenhouse gas emissions with CO2 equivalent units is the value that we are referring the whole time. Okay, is the way not to just use or provide information of amounts of energy, provide information about amounts of material, distances, etc. We translate everything, each step of the production and the life of the product in one unit, the CO2. Okay. So the idea is that the LCA, we will see in a minute the scheme that we use. It's a way to take into account every step. Into that, the first step of the production, in the case of cork, we have the forest. And the forest, in that case, with natural materials, we have to take into account that they are made by organic material that has carbon inside. So that carbon is obtained by photosynthesis. So the forests are a carbon sink, all the forests. And also the coke forest. So they can contribute to that climate change mitigation because they sequester the carbon dioxide from the atmosphere. That's the definition, because the cork oak forest is a carbon sink. Because of that, we have to take into account that step, that it's not common in the whole products, just with the natural products. They take the carbon from the atmosphere, and that carbon is fixed into the biomass of the tree, the forest, etc. So the sequestration, in that case, we emit carbon by respiration, we fix carbon from the atmosphere by photosynthesis, and the result is the carbon sequestration. Okay, so that's important for all natural materials. And when we calculate the LCA, the life cycle assessment, and the quantity of CO2 emitted, we have to take into account that kind of value. Here we have a table of different amounts of carbon fixation of different kinds of cork oak forests in different countries. So more or less from 2 to 14 tons of CO2 per hectare a year could be fixed into forest, in the cork oak forest. So that's a quantity that we have to put in the calculation of life cycle assessment and carbon footprint of the cork products. The idea here is that we have a negative value in most of the cases of the carbon footprint of cork products because of the carbon fixation by the forest. So if we take into account that the production could emit a certain amount of CO2, then the forest has here a lot of CO2 fixed in their biomass. So we emit a few quantity of CO2, but if we take into account the amount of CO2 fixed by the cork biomass, the result will be negative in that case in the whole sector. Okay. Here we have that different values of carbon footprint of cork products. In the literature, we can find a lot of studies with cork stoppers, and all of them you will see here at the bottom of the table that the result is negative. What does it mean? It means that the cork product retain more CO2 than emits. So that's incredible. That's as a sustainable material, it means that if you put cork material into a product, the carbon footprint of that product will be less. So that doesn't happen in any case. Okay. Well, here you have the amounts that I said before. As you can see, is negative, all of them. And now let's explain a little bit about life cycle assessment, what it is. In fact, there is just, I would say, two main aspects that would be useful for a sustainable evaluation of any material. First of all, the design. The design is the most important aspect when you try to produce a sustainable material or sustainable product, sorry, because it's the process that you can think the whole possibilities of the product. The first question is why you need that product. Is the first question that you have to do, and then try to consider all the inputs, outputs, possible impacts, etc. of all the steps. Where I found the raw material, how I produce, which is the packaging that we need, how will transport, how will provide that material to the final consumer. Okay, important. During the use of the material, the material or the products or the product will need energy, more or less energy, and important again, the end of use. What we will do with the product at the end of life, disposal into landfill, we will recycle, etc. We have to consider the whole phases in order to know if a product is sustainable or not. We have to calculate the impacts in each step in order to calculate the carbon footprint. Okay. Then, in order to calculate that carbon footprint, we have to use methodology, standardized methodology. Okay. In that case, we are now evolving and designing a methodology for cork stoppers in Spain, but there are another specifically for cork stoppers. But you can use LCA standards for any product. Sometimes there are LCA standards specifics, sorry, for one product, but if not, there are general rules in order to calculate the life cycle assessment. In the case of cork products, as I said before, we have to take into account the forest management of the cork, how we extract the cork from the forest, then how we transport the cork from the forest to the preparation site. We have to know that, as you already know, the cork is based in the Mediterranean basin. Okay. So in the preparation, we will need water, energy, some kind of maybe petrol or whatever that we need to boil, for example, the cork. And then if in these cases we are talking about cork stoppers, after the preparation, the cork material has to go to the cork stoppers manufacturer. Here we have different steps. So we will need energy, products, electricity, maybe chemical products, etc. Okay. So here you can say that in each step we have to try to understand and to verify and to calculate and to identify if we will need energy, products or services or packaging in that case, in order to do a good calculus of that life cycle assessment. So after the production, we have to take into account also that that product will go to the wineries. Maybe the winery could be located here in Spain, or maybe in Europe, or maybe in the US. I don't know. And then during the use of cork stoppers, in that case, we won't need anything, but in the case of other products, it's important to know if we will need energy or services or products or etc. In order to use the product. And then the disposal. In the case of cork stoppers, the disposal could be the end of life, into landfill, or into composting, or into some kind of recycling facility. Okay. Then after seeing that a quick example of life cycle and different steps, here we will show you the different LCA results of different products. As I said before, we have several studies of cork stoppers because they are the most used cork material function. Okay, but there are another subjects made by mainly agglomerated cork. For example, here you have the carbon footprint of different cork products, and you can imagine that if the product has more glue agglomerate and less cork, the impact is bigger. So, for example, in the champagne cork stoppers, you have more agglomerate, more glue, and the impact is more. And natural cork stoppers made with one piece of natural cork, the impact is much less. But then we have to take into account the fixation of the forest. You have to remember that. And also, here you have the amount of CO2 included into each product. In the case of cork stoppers, natural or agglomerated, and in the case of different slabs, expanded cork slab for construction, for example. So at the end, it's important to keep in mind, I would say, three things. What is the If you want to understand if one product is sustainable, more or less sustainable, we have a tool. The tool is the LCA, life cycle assessment process, that give us a result. A result is amount of greenhouse gas emissions for a unit of product or service. In this case, CO2, the unit will be CO2 equivalent. So in order to compare different products, we can use that methodology, and we can use and look after the CO2 equivalent for each product. So it's the way to compare, because it takes into account the whole process of the product. And then at the end, because the core products has, most of them, they fix CO2 from the atmosphere, it means that they are a very sustainable product compared with plastics and others. So in the case of aeronautical sector, the core product could be a natural alternative and very good alternative in order to achieve a more sustainable sector.
At last, but not at least, let's focus on potential uses of cork. I'm going to talk about main properties of cork, cork formats, and examples of cork in construction, design, textile, mobility, pharmacy, and cosmetics, and some other examples or applications. Ready? The goal of this unit is to get an introduction of different uses of cork material and the characteristics that make it suitable of the aerospace sector. Cork is the outer bark of oak tree, as it says, and the physical and mechanical properties of cork are the result of the cellular structure and the chemical composition. Cork's macroscopic cellular structure is widely established and well known. Robert Hooke in 17th century is the first person who saw it, and he described as the honeycomb. Cork is an anisotropic material. That means the cross section of radial direction resembles a honeycomb with polygonal cells with 4 or 9 sides. Besides the tangential or axial cross, morphology is comparable of brick wall or prismatic cells. The chemical composition of cork is suitable, different from the other parts of the tree. T-shirt, it's a specific result in some gaps in knowledge of the structural and chemical composition of cork. Cork chemical composition is dominated by the presence of suberin in the primary structural cell wall and compartment, and by its close associate with other components, primarily lignin and non-lignin aromatics. Sorry. The structural composition of the cell walls are by order of relevant importance: the suberin, the lignin, polysaccharides, the extractable substance, and inorganic components. In the cell wall, suberin and lignin. Suberin, lignin, and hemicellulose build a fraction, build up a particle strong and chemical resistant assembly. There are some gaps in knowledge regarding of the structural components of cork, but there are 3 points that are relevant. That's the first one is the suberin is the main component element of the cell. and it is flexible polymer. Lignin represents about 1/3 of the cell wall material. It gives bulk and rigidity to the structure. Finally, the cellulose has a lesser role in the construction of the cell wall, and its proportion should be less than 10%. In the cell wall, the sovereign lignin and hemicellulose fraction build up a spatially strong and chemical resistant assembly. So the composition, the chemical composition of the plant cell wall have two types of components: the structural components and the non-structural components. The structural components and macromoleculars of polymers, natural polymers that build up the cell wall and define its structure, and the non-structural components are either low molecular organics components that may be solubilized by appropriate solvent. The first component that we are going to describe is suberin. Suberin, as it says, is the main structural component of cork. About the 50% of the total material of cork cells are suberin. Suberin is not a specific component of cork. It is found in the periderm of the plants, but in much less proportion than the cork. Suberin is a flexible polymer made up of fatty acids, alcohol, and glycol, mainly long-chain aliphatic chains linked through the ester links. While the monomeric composition of suberin and the links between monomers is quite well known, the macromolecular, supramolecular structure are still unsuitable unknown. Lignin is a cross-linked polymer of aromatic nature. It is the second most important structural component of cork, where it's amount 20 and 25 in the total material. It contributes to the structural rigidity and compression resistance of the cell. Lignin compresses 3 phenylpropene monomers, the p-hydroxyphenyl, it's the H-lignin, the guaiacol, G, and the cyrillignin, the S. Cork type lignin is the G-type lignin, and there are also the non-lignin aromatic, where estimate the amount of a half of the total aromatic in the cork. Lignin molecular are branched and complex structure, where the phenylpropenoid units are linked by various types of covalent bonds. Polysaccharides have the less role in construction of the cork cells. The structural polysaccharides of the plant cell walls are cellulose and hemicellulose. Cellulose is a linear polymer of B-glucose molecules linked together via beta 1 to 4 glycoside bonds. In a long chain contains several thousand of hydroglucose units. In the cork cell, cellulose is located in the primary wall, and its tertiary wall provides a resistance against the tensile stress, and its proportion should be less than 10%. The hemicellulose is mainly composed of chilenes and arabinose monomers, and it also has a similar proportion of cellulose in cork cells. Compared with cellulose, hemicellulose are smaller, branched polymer, amorph, and more reactive. The monomers that are found in hemicellulose include pentoses, hexoses, and uronic acid, and there are some others. And the presence of hydroxyl group allow the V and the H bonding. Extractive are low, medium molecular weight molecules that may be removed from cells by solvent extraction without affecting the cellular structure of the material and its mechanical properties. In cork, the amount of extractive is higher than the wood, and they are very variable from 8 to 22 with average value of the range of 14 to 18 on percentage in cork. The extractive may include hundreds of different molecules, but can be classified by aliphatics and phenolics. In the aliphatics, it means that it can be removed with a solvent with a low polarity, and here we can find the long chain aliphatic molecules and terpenoids, and phenolics. It can be struck with by a polar solvent, and here we found phenolic compounds. And then there's the inorganic compounds of lignocellulosic material are usually the H content, which represents the solid residue after total combustion. Cork has a rather low H content corresponding to values between 1 and 2. Calcium is the most important element, followed by the phosphorus, sodium, potassium, and magnesium. So the chemical composition of cork are H's, extractive, suberin, lignin, and polysaccharides, and the method of chemical analysis based on that is a serial extraction in order to find all of these components. As it is said, the chemical composition of cork and the cellular structure give to the cork an usual combination of properties like low density, very low permeability, low conductivity, chemical stability, durability, and high compensability with a good recovery. So the physical and mechanical and thermal properties of cork can be summarized in 10 points, or decalogue of cork, as it can be seen on the screen. So let's focus to the first one. Cork is a light material and floats on water. This is the result of the air in the cells. Cork cells have the 90% occupied by air. It is a very light material and has a low density. Is one of the features has been widely used in floatability elements. Impermeability. As cork cells are about the 90% occupied by air, it could be seen that the liquid can fill the space, but the cork composition, for example, suberin, provide a higher impermeability to the liquid and gases. Thanks to the high content and the size of the cells, the heat it has a very low heat transmission, and the low density and the high porosity cause the most of cause the most of the sound wave to be absorbed and transformed into a heat. And cork has a high resistance to the movement. The cellulose structure causes the suction effect, and this property is very important in cork stoppers of closings, the bottles. And the cellular structure allows the deformation by flexion of the cell's walls. As in the previous cases, the propagation of mechanical wave can be disappeared to the surface. This property that the shock absorbing capacity is very important for some applications, such as the seismic joints or suspension joints in the buildings. The cell's high air content allows the cork to be compressed to almost its half without losing flexibility, and to resign its shape and volume when it is no longer pressed. So it is compressible, elastic, and flexible. Lignin and polysaccharide in its wall give it rigidity, and these components provide the core resistance to the passage of the time. Cork is a hydrate, depending on the environmental conditions. The moisture content of cork condition its mechanical properties. Moreover,
we
several
have been
researchers
talking
have
about
found
the most important properties of
shown
cork,
the potentials used,
and
from
here
the potentials
we
of
will
cork
talk
to
about
remove
different
emerging
examples
pollutants, such as
of where cork can be
polycyclic
found.
aromatic
So
hydrocarbons,
we would like to do
heavy
a little
metals, pesticides, and
Next,
other components. And
here in this slide,
it
you can
is,
find some
cork is
statements
natural
that,
material,
if you want
because
to pause
it is the
the
outer
video,
bark
you
of
can
cork
read
tree.
it and think about
Oak
if
tree
they are
can
true or
regenerate cork
false,
bark after each
and then
harvesting.
start
As the natural material, it
playing
can
again
be
and see if
recyclable
they
in
are
a
true or
compostable
false.
bin. So there are the 10 properties of cork. After the game, what formats of cork can be fine? Some ideas. When we think about cork, maybe cork stoppers, cork boards, or came to our mind, but there are much more formats of cork. Let's see it. There are cork plates, and there are pieces or the whole plate. Cork stoppers, reused or cork stopper, natural or agglomerated. Granulated cork with different sides and origins. Agglomerated cork or thermospanding with different application depending on the formulation. Cork composite, this is the new file of the cork industry. There are different formulation according to the application. Sorry. Cork textile for the fashion and decoration, and there are a lots of application. As you have just seen, cork has different formats and they can be used in different applications. So let's start with the construction. We can find cork in construction, outdoors, agglomerated or projected indoors on the floor, into the walls, or in the walls, and in the suspension joints, as it is said. Depending on the application, different cork agglomerate can be found. Each new cork formulation will have its specifications, and it's important to know them before using. anything you can imagine can be designed. With cork, here we have some examples made with the students of the degree in design in Barcelona. And we can find cork in textile, in fashion industry, used like a leather. And due to its potential for of impact energy absorbent application, this material has been employed in a great variety of applications, such road helmet, vehicle passive safety, or other formats that you can see in the picture. At last, we are going to talk about the cork in pharmacy and cosmetics. Cork and its byproducts can be an important source of multiple bioactive compounds, such as phenolics, acids, terpenoids, and tannins. These bioactives have a variety of relevant properties, so they can be used in cosmetics and pharmacy industry. Has been cork used in aerospace? Yes, it has been used. Hamorim has different examples. You can find it different studies about that. So the conclusion of the unit 3 of chapter 2 are as follows. Cork is the outer bark of cork tree, as it is said. The physical and mechanical properties of cork are the result of the cellular structure and chemical composition of the plant. Cork has an unusual combination of properties, like like low density, very low permeability, low conductivity, chemical stability, durability, and high compressibility with good recovery. Different types of cork formats exist. Each type of cork format has its properties. Different applications can be made with cork: construction, design, textile or fashion, mobility, cosmetics, pharmaceutic, and aerospace. So let's play with cork.